Alright, so now we're going to add a little bit to this absolute value. Let's say we have the absolute value of x plus 4 equals 10. Well, we know that this absolute value still represents distance in the positive direction and in the negative direction. So we have x plus 4 equals a positive 10 and x plus 4 equals a negative 10, or 10 in the negative direction. Then we go ahead and solve. X equals 6, subtract 4 on both sides of this equation, x equals negative 14. So in this case, x equals either 6 or a negative 14. Now, what if it gets a little more complicated? What if we have 7 times the absolute value of x plus 4 minus 14 equals 35? Well, we just run away, right? No. We do the same thing that we've always done. We treat this absolute value as a variable. We're not going to adjust anything on the inside of it until it is isolated by itself. So we're going to isolate it by adding 14 to both sides, because that's the first thing when we're working backwards in the order of operations. We get the 7 times the absolute value of x plus 4 equals 49. We're going to isolate by using the inverse operation of division to take away the 7 times. And we have x plus 4 equals 7. Now that the absolute value is isolated, we have x plus 4 in the positive direction, x plus 4 in the negative direction. So we get minus 4, x equals 3, or x equals negative 11. The key to absolute value equations is to isolate the absolute value and then create a formula for the negative direction and the positive direction. Remember, even something like this, a negative 3 times the absolute value of x plus 4 equals 6, we need to isolate the absolute value first, and we get the absolute value of x plus 4 equals a negative 2. Well, our absolute value can never equal a negative 2, so we know that this equation would be no real solutions, or the empty set.